Okay, hello everyone. So very welcome everyone to our Seed Ranger Training March session. So today we will be explore the capabilities of our reCamera integration and our multiple camera deployment on Jetsons. I'm Allison from the Seed community team, and today I'm glad to invite our team member Bianca and Haiten to be our speakers to share about Vision AI security. So before that, I'd love to share some backgrounds about the Ranger program. So over the past few years, we are receiving lots of Ranger applications from around the world. From now, we have more than 150 applicants for our Ranger program, and we're very glad to see that. The reason why we are starting Ranger program is that we are hoping to lower the threshold to the community to learn about the hardware and how to solve the problems related by our community members. And this year we are upgraded our Ranger program from 2.0 to 3.0 is that we are hoping to receiving more of community members who are system integrators or solution makers, etc. And we are hoping to invite them with us together to make the hardware like IoT or AI solution more mature and more suitable for the local and to solve the traditional industries problems. Okay, so today we are talking about the reCamera and Jetson. So if you having one device on hand, then later you could try some hands-on practices and some of the tasks after this training. Okay, so after this kind of background information, I'd love to officially start today's training. And firstly, I'd love to invite everyone to do a briefly introduction about yourself. So you can share your name, like your background, and what kind of problem that you are facing, and what kind of expectations you would love to receive from today's training. Any volunteers? If nobody is interested with this part, then we will go officially to the sharing part. Okay, so let's welcome Bianca to share the L1 of our sharing today. Hello.
Hello,
So
so my name is Bianca, and I'll be your instructor for the session. Today, we have around an hour together, and our goal is quite simple. It's to move from seeing AI to building it. You'll be spending most of your time hands-on if you have the reCamera. So, 1 second, I'll pull up a video. One sec. Okay. So right now, what you're seeing is just a normal dashboard with a camera preview. But wait 1 second. Okay. When I move into view over here, the data changes, and you can see over here, it's a live heat map. Okay. So what you saw in that video, the short video, was basically a basic video stream. And when a person enters the camera view, the AI takes over, and you can see the metadata overlay identifying the person, for example, me, with high confidence. And as soon as I step out, the detection disappears. This is also creating a real-time occupancy heat map. Oh, sorry. Okay. So all of this happens in real time, and it goes from detection to push notification, taking almost less than 3 seconds. Okay. Now that you've seen an example, oh, this is not changing. 1 second. Okay. Now that you've seen the live detection, let's talk about where this actually lives in the real world, specifically in retail and customer interaction. So take a look at the top left image. Below just seeing a person, the system generates a pedestrian flow heat map, which allows store owners to see exactly which aisles are hot and which products are being ignored. We aren't just counting heads, we're tracking the flow of people entering and exiting to optimize staffing and layout. In the center, you'll see the live dashboard, which I showed previously in the video. This is where all the data is aggregated. On the far right, we have the trigger conditions, and this is where the magic happens. So you can set the system to send an alert if a queue gets too long or if someone enters a restricted area. And finally, for those who are worried about compliance, we also have an automated video mosaic. The AI can identify a human and instantly pixelate their face or body in the stream. And so this will ensure protection for privacy without losing valuable data. And then lastly, what you see in the bottom left is the actual brain of the operation. So the edge server and the camera setup. The camera is what we'll be working with today. So what is the dilemma of traditional surveillance? It usually boils down to these 4 cases displayed on the PowerPoint. So first we have the human limit. We can't watch everything at once. So we need a system to watch it for us. And then we have the false alarm storm. So traditional motion sensing is quite noisy and unreliable, and we need intelligence, not just motion detection. And thirdly, there's the barrier to entry. So smart used to mean expensive, but we're going to show you that that's no longer the case. And lastly, there's the analysis paralysis. With so many options, people don't even know how to choose. If we take a look at the image on the right, that tangled mess of wires and cameras, that's what happens when you try to solve modern problems with outdated tools. So let's look at how we can clean that up. We'll start with the first story. It's so we'll start with an example story. We call it the security guard Lao Wang's daily routine. So Lao Wang, he's a security lead at a factory, and his job is a tough one. He's responsible for over 16 different screens for 8 hours a day. Now, research tells us that after just 20 minutes of staring at a monitor, a person's attention span drops by 50%. It's just human nature. We aren't wired for that level of repetition. So, what happens when someone actually scales the factory wall? In that exact moment, Lao Wang might be grabbing a coffee, checking a text, or just spacing out for a second. And that's the fundamental flaw. Traditional surveillance is just an incident recorder. It's great for seeing how you got robbed, but it really doesn't do anything to stop it. By the time you're reviewing the footage, the damage is most likely already done. For the second pain point, we have the limits of smart technology. Our second story is about the ceiling of smart tech. 1 second when it loads the PowerPoint. Okay. So our second story is about the ceiling of smart tech. Imagine a factory that wants to automate, for example, safety helmet detection. Traditional vendors provide a quote starting at around 500,000. And to make it work, the factory is forced to buy brand new proprietary cameras and expensive servers. For a small to medium-sized factory, that 500,000 might be their entire annual profit. And the math just doesn't add up. So the result, they're forced to abandon the smart solution and go back to having people stare at screens. This is the reality. So for a long time, the barrier to entry was so high that if you weren't a massive corporation, you were priced out of safety. Today, we're going to show you how to break that ceiling. Next, we're going to look at a third point. So our third story is about the selection trap. And what I mean by the selection trap is, for example, a small convenience store thinks they need the best equipment, top notch. So they'll buy, for example, a 16-channel industry grade equipment. It's quite massive overkill, but probably a total waste of their budget. And most of that power sits idle. On the flip side, you'll have large scale factories trying to save costs by buying, for example, lightweight entry-level gear. The results? Well, insufficient computing power, constant system lag, and a setup that's essentially useless for their needs. Choosing the wrong equipment either drains your bank account or fails to do the job. And for most customers, the real dilemma isn't wanting the tech, it's simply not knowing where to start. So now I'll talk about the fourth and last pain point, and then an application case. For example, the false alarm storm. Imagine a production facility, and it's using standard motion detection. These systems are blind, basically. They trigger an alarm the moment any pixel changes on the frame. So we're talking about almost 200 alerts every single day, where 90% of them are just shifting shadows, wind in the trees, or a stray cat passing by. The security team would spend maybe around a week chasing these ghosts, only to find probably nothing. And what happens next is basically the boy who cried wolf effect. The staff, they stop looking, they stop caring, and they eventually just mute the notifications. And that's the real danger. So when a genuine intrusion finally happens, it gets completely drowned by junk. And in the world of security, a high false alarm rate is actually worse than having no alarm at all. And because it trains you to ignore the truth until it's too late. So for our specialized application, for example, imagine industrial inspection for the rich mini production line. On a high-speed line, humans face three major unresolved issues: verifying if a server is installed correctly, confirming the firmware has been flashed, and matching the right accessories to the right unit. So doing this manually is slow and prone to error. Our solution uses a three-layered AI approach. The first one being character recognition to see the parts. So you can see over there in the photos, we have the parts labeled with 1 and 2. And then we use OCR to match serial numbers against the work order. Then we use an automatic database entry via QR code scanning to log every unit's birth certificate instant. So instead of workers squinting at tiny labels, the AI will handle the verification at the edge, ensuring that there is no faulty units to ever leave the station. That's much better than the original situation. So now that we've seen our pain points, you might be asking yourself, is there a solution that can solve all four of these problems simultaneously? The answer is yes. And that's what we're introducing today, Edge AI Vision. So what is Edge Vision AI? Edge Vision AI is, to simply put, we're letting the camera understand the scene for itself. So in a traditional AI setup, the camera is just like a dumb eyeball. It captures footage, sends it to the cloud, waits for a server thousands of miles away to think about it, process it, and then it sends back the results. That process can take anywhere from a few seconds to half a minute. Plus, you're sending quite sensitive video data outside your walls, which could be a major privacy risk. Edge AI flips that model. So the camera has its own built-in AI chip. So the analysis happens locally. This is quite important. And because the brain is right there on the device, the results are also instantaneous. So there's zero latency. The data never leaves the system and it keeps it secure and private. So it's faster, safer, and much more efficient. So let's just break down the journey of a single frame of video. And on the left, you see the traditional AI solution. The camera will capture the image, then it has to shove all that raw data up into the cloud, and a server somewhere else does the thinking and eventually sends back a result. And the hop to the cloud creates a multi-second delay. And every time data leaves your building, you're opening a door for potential privacy risks. And now if we look at the right, we have Edge AI solution. And this is what we're building today. We've integrated the AI chip directly into the camera hardware. So as was said before, the analysis happens right there in the little camera. And there's no waiting for the cloud. So you get instant results. And most importantly, the data stays local. It's a closed, secure loop. And then, well, you can be asking yourselves, where do our advantages lie compared to traditional solutions? In this case, we have 4 dimensions. The first one being the deployment cycle. So traditional solutions require custom development starting from several months. Our solution is ready to use out of the box. So with verification completed in hours. Second, hardware binding. So traditional manufacturers require you to buy their cameras, but we support any RTSP video stream. Your existing cameras can most likely be used directly. And thirdly, computing power flexibility. What we mean by this is that traditional solutions are fixed once purchased, but we have light nodes and strong nodes that can be matched according to your needs. And fourth, our system is open. So traditional systems are basically like black boxes, but we're an open source solution. So you can see the code. And so we just mentioned the computing power flexibility, and I'll elaborate on that here. So we have 2 types of hardware corresponding to different scenarios. So the reCamera is the light node. It's compact, inexpensive, and plug and play. So basically, a small convenience store can handle its needs with the reCamera, and it would only cost a few hundred RMB. Jetson is the strong node. So it has a strong computing power and it can handle around 8 to 16 camera feeds simultaneously. So large factories would use Jetson for unified management of dozens of feeds. And with this, you choose based on your needs. So ensuring almost no waste. And then we can ask, in what scenarios can this solution be used? For example, we have property security. So for perimeter intrusion detection and nighttime alerts, factory safety, as the example I gave before for safety helmet detection or violation in identification. We can have the commercial retail setting where passenger flow statistics and heat map analysis are used. Agricultural monitoring for pest and disease identification and animal invasion alerts. So these are just many scenarios, but the core compatibility is the same, enabling the camera to understand the image. Now we'll move on to the hands-on experience. So I just wanted to ask, who here already has a reCamera on hand? Nope. Okay, then I'll just walk through the steps, and this can be basically like a homework for later. So I'm not sure, are you guys familiar with Node-RED and this type of interface? Yeah, okay. So for the reCamera, this is the web interface, and it allows you to access directly through your browser. So first you would enter the home page, and then you could see different application plans and click on any application to deploy it. In this case, we would join the SenseCraft web page to find the applications. And then you would just either connect it via USB or enter the camera's IP address. And then over here on the image, you can see the actual panel. On the right side is the control panel, which allows for model selection and parameter adjustment. And also you can drag in the nodes to start your flow. So for this exercise, there's 3 core concepts that need to be applied in practice. The first one is the confidence level, and this is how certain the AI is that its detection is correct. So for example, 95% means very certain, while 60% means less certain. And threshold can be adjusted, so setting it higher reduces false positives and fewer incorrect reports, but it may increase false negatives, so it would miss some actual events. Setting it lower increases detection, but also increases false positives. So you need to find a balance. The second is the IOU, the intersection over union. And simply put, this is the filter that duplicates bounding boxes. If the same person is boxed twice, the IOU helps merge them into a single target. And third, we have the testing zone. So this is the most important concept for this exercise. You can draw a specific area on the screen and only monitor targets within that area. So this is the key to resolving false alarms. It would only report what you care about and not just everything. So as you can see, here is the line to draw, and anything recorded over here won't be detected. And once you complete this task, you'll have your camera connected and it should be ready to deploy. So how are these linkages configured? The next workshop, the L2, will teach this in detail. So Node-RED zero code linkage, configuring automation via drag and drop, and then Jetson and Frigate multi-channel access, home assistant, and cross-system integration. And lastly, I just want to highlight some boundaries of the solution capabilities. So what it can do, it's target detection, area intrusion detection, alarm push notifications, and cross-system linkage. What we can't promise First, we do not promise 100% accuracy. So no AI system can guarantee 100%, but accuracy can be optimized by adjusting parameters. Second, we do not perform facial identity recognition. So this is a compliance red line. We only identify if a person is present and not who the person is. And third is it is not to be used for safety critical decisions. So it's an assistive tool and cannot be used in scenarios like autonomous driving brakes or medical diagnostics. Yeah, that's about it. So thank you for participating for the L1, and now we'll move to the L2 workshop.
Good afternoon, everyone. Can you hear me? Okay. Let me share my screen with you. Okay, everyone. Mm. Okay, everyone, let's start. Good afternoon. This is Haytham, and today we've got about 45 minutes together. We're going to go through how to actually pick the right hardware for a project. Then we walk through the reCamera pipeline and the Jetson pipeline, and we will wrap up with some consultant level stuff. So let's jump in. So in the part one, solution selection capability, we will be able to provide professional recommendation based on client needs. Performance review and the L2 target definition. So let me throw some quick questions at you to set the stage. So first thing, like what's the camera actually good at? So it's basically, it does edge AI detection right there on the device with no cloud. And how's it different from Jetson? So we must think of the reCamera as a single point node, lightweight, on one camera. But the Jetson is the aggregation beast, multiple streams flowing in. And remember the L1 demo where someone walked in front of the camera and it detected them? But who actually set that up? So today we're cracking open that black box. So we have 5 core capability objectives. You'll know how to pick between reCamera and Jetson when a client asks, not guessing. So actually knowing why. You'll understand how to wire AI detection into smart home automation. We'll cover frigates for managing multiple cameras, and we'll also talk about false positives. Honestly, the most annoying thing in real deployments. And you'll see how Node-RED lets you build real automations without writing a single line of code. So here's how today breaks down. So the first half is all about the reCamera. We'll go through the Node-RED and how it talks to Home Assistant, the whole flow from person detected to red lights to Telegram notification on your own phone. Second half is Jetson territory, frigate, multi-camera setup, all the automation around that. So at the very end, I'll share all the documents and resources with you and your homework. Replicate everything we go through today and send me the results. Okay, let's get into it. Before we touch any tools, let's talk hardware selection. Because when a client comes to you, you don't just throw a product to them. You ask the right questions first. What are they trying to monitor? Where does it need to run? How real time does it need to be? And also, how many camera streams are we talking about? Once you get those answers, honestly, the right solution kind of picks itself. So you must think of it in 3 tiers. The reCamera is your lightweight, all-in-one option, single stream, fast to deploy, cheap. And the Jetson is your edge gateway, multi-stream, serious computes, you can scale it. And then there is the cloud, if you need to go really big with multiple models. But that comes with higher costs and more maintenance headaches. So the key is knowing where each one fits. So this is a big picture. Every edge vision AI system has 3 layers, and this is worth remembering. You've got the input layer, basically the eyes, your recameras, whether that's a reCamera or regular RTSP cameras. Then the compute layer, which is the brain. That's where AI actually runs. So reCamera handles it locally for simple stuff. Jetson for when you need multiple streams. And finally, the action layer, the hands, Node-RED and Home Assistant. They close the loop. Person detected, lights go red, notification sent. That whole chain is what we're building today. So let's apply what we just covered to some real scenarios. So picture a small retail store, one camera, tight budget, needs to be up fast. That's reCamera, right? Now a warehouse, 8 cameras, centralized monitoring, multi-zone alerts. So that's Jetson territory. And then remote access across multiple sites. That's where you start thinking cloud or hybrid setup. The answers are on screen. You can take a look. So a quick detour on something important, encoding. Here's the thing. Raw 1080 pixels video is like 1 gigs per second. No network handles that, and no edge device will handle that across multiple streams. So encoding compresses it for transmission, and decoding unpacks it on the other side. So the AI can actually process it. So this is the foundation for everything we're doing next. Keep it in mind. Now here is where it gets real. When you're running 4 to 16 camera feeds, every single stream has to be decoded before the AI can even look at it. That eats CPU, GPU, memory, and almost everything. So this is the hidden bottleneck that trips people up. When a multi-camera setup is running slow, it's almost never the AI model. It's the decoding pipeline sitting upstream that's choking. That was the video streaming foundation. Everything coming next builds on that. So let's keep going into AI processing speed. So two numbers you need to know when evaluating AI speed. TOPS is the hardware's compute power, and think of it as the engine size. So it's heavy. The model is that's the car's weight. You need to match one to the other. Big engine, light car, fast, small engine, heavy car. So you're going nowhere. Here's a practical formula you can actually use. Take the client's FPS requirements, multiply by the models. That gives you the total compute demand. So you convert it to TOPS, throw in a 20, 30% safety margin, and now you're not guessing anymore. You can say this is the exact hardware is rated for your workload with headroom. So that's the difference between being a technician and being a consultant. So we've already covered encoding, TOPS, and how to size hardware. Next up, I want to show you a single framework that pulls out all these selection dimensions together. This is basically your recommendation templates when you're advising clients. So there is 6 dimensions to evaluate: processing power, stream count, real-time performance, stability, scalability, and engineering constraints. You don't need to memorize the whole table, but definitely remember this conclusion template. It's what you use to walk a client through a structured recommendation instead of just winging it. You can write it down or take screenshots. So we have two completely different pipelines here. reCamera is simple. AI runs on the camera, pushes to Node-RED, action happens. 3 steps in one device, and it's done. Jetson is a different animal. You've got multiple RTSP streams coming into frigates. Events go out over MQTT Home Assistance, picks them up, and one Jetson handling 8 to 16 feeds at once. So here are some key things to remember here. reCamera runs AI locally, right on the camera itself. With Jetson, the cameras are just capturing video. They're done. All the AI runs on the Jetson box. So reCamera for quick validation and simple stuff. Jetson when you need to aggregate multiple streams and do complex automation. All right. Now, let me walk you to the part two, reCamera in-depth practical applications, Node-RED zero code integration from detection to push. So this is the Node-RED interface for areas to know about. On the left, you've got your node library. Center is the workspace where you drag and connect things. And the right side is the debug window, which is the first place you need to look when something breaks. And on top right is the deploy button. pretty straightforward. Now the detection results only show up in the debug panel by default. If you want a proper monitoring interface, something visual, Node-RED will use UI template for layouts and UI text for displaying live data. So this is what you'll set up at home. Here's what the reCamera workspace looks like. On the left, you see the initial setup. Just click through the prompts, decline notifications when it asks. On the right is the workspace with your model loaded. You should see YOLO V11N detection as the active model. This is what you'll be looking at when you do it on your own. Here's a quick tip. See that settings icon in the top right corner that opens the menu for import and export. And there is a shortcut too. If you click Ctrl Alt I, it will opens the import dialog directly. So it will help you save your a few clicks. And on the right side, that debug panel, that's your best friend. Always check there first when something isn't working. So the workflow imports is pretty simple. You open the import dialog, drop in the Jetson file, hit import. The flow shows up on your canvas, hit deploy, then check the debug panel. You should see detection output come in through the in real time. That's how you know it's working. So this is something cool, the MQTT auto discovery. Basically, Frigate automatically tells Home Assistant about its cameras, person counts, detection states, everything. No manual configuration on the Home Assistant side. So Frigate publishes discovery messages and Home Assistant picks them up and create the entires for you. So the camera feeds, person count, sensors, detection states, all just appear, one mechanism and everything connected. You can think of the MQTT like a postal system. You've got a broker that routes messages, a topic, which is basically the address, publish sends the message, subscribe receives it. So in our case, the Node-RED publishes to the light bulbs topic, and the bulb is subscribed to that topic. So message arrives, bulb acts. That's literally the entire logic. Now for the function node, this is where we extract the detection data. You drag a function node into the canvas, double click it and paste it in the code you see on the screen. I can share it with you later. So what this code does is it's pull the person count out of the SSCMA detection outputs, grabs the number from the result string and passes it downstream. So you connect it between the SSCMA node and also the debug node. So you click deploy and check the debug window and you'll do all this easily. So the MQTT setup is straightforward. You drag an MQTT out node, add the broker. Server is the Jetson's IP port 1883. Deploy it and check the status. If it says connected, you're good. If not, it's almost always either a wrong IP or the Jetson isn't running the MQTT broker. So here's the first real automation, which is a person detected. Light turns red, 4 nodes, CMA for detection, a switch node to check if detections isn't empty, change node that sets the payload to state on with red color, and an MQTT out that publishes to the lights topic. So you connect them, deploy, and light response to detection. Pretty satisfying when you see it work. Here we will discuss the Telegram notification pipeline. The full picture, reCamera detects a person, send an MQTT message to the Jetson broker, Node-RED picks it up, calls the Telegram API, and boom, push notification on your phone. 5 steps, fully automated. Someone walks in, you know about it within seconds. So this is exactly what your replicates. So here we have 2 dashboard cards you'll set up. The first one is the live video feed from reCamera, real-time view. And the second one is the person count, display using a template sensor. You'll create a new dashboard, view called reCamera monitor. The code on screen uses Home Assistant's Jinja 2 templating. So those double curly braces pull live data from your sensors automatically. So you don't have to worry about memorizing the syntax. It's all in the docs I will share with you. So in Home Assistant, you'll find the hacks. That's the community store for third-party integrations. This is where you get the reCamera integration from. In Hacks, you'll add this custom repository. The URL is on screen. One-time setup, then it stays and auto updates easy. Then on the integrations page, just search for a camera and add it, and that's it. You'll need some YAML snippets for the configuration, and don't stress about writing them from scratch. I share the HTML config tool after the session that generates clean YAML for you automatically. So on the dashboard, you'll hit the pencil icon to go into edit mode, then add a vertical stack card that groups your cards in one column. So inside that, you add a picture entity card for the live video. The red arrows on screen show you exactly where to click. So when you do this, just follow the same sequence. For the picture entity card, set the type of picture entity, select reCamera live stream from the drop-down, camera view set to live, and you'll see the feed pop up right in the preview. Pretty cool that you get the real-time video directly in Home Assistant without needing a separate app. So also you need to edit Home Assistant's YAML config at some points. One thing to remember, the YML is really picky about white space. So spaces only, no tabs, and indentation has to be right. If something breaks, it's usually an indentation issue. So checkpoint, your dashboard show now the live camera feed with detection overlay, and the reCamera live label confirms the stream is active. The detection bounding box should follow movement in real time. So if you see this working, the reCamera to Home Assistant pipeline is fully connected. If not, check your MQTT broker connection and entity configuration. So we have 5 steps to connect or create your Telegram bot. Step 1, you open Telegram and search for bot father, and then send new bot and follow the prompts to name your bot. Step 3 is to send to the ID bot to get your personal chat ID. After that, you save both the API token and the chat ID. You'll need them in the next configuration. Step 5, you keep your IPA token private. Anyone with this token can control your boat. So the screenshot on the right shows what the boat father conversation looks like. A Home Assistant's MQTT setup, you just go to settings, then devices and services, then add integration. You search for MQTT, enter your broker address. For our setup, that's the Jetson IP on port 1883. So once it's connected, MQTT entities from Frigate and reCamera will auto-populate. So this is the backbone connecting all your devices to a Home Assistant. So you need to add the Telegram bot integration to Home Assistant. You go to integrations, search Telegram bots. Something critical, which is you need to select polling mode, not webhooks. Polling works behind NAT and firewalls without port forwarding. So after that, you enter your API token and chat ID from the previous step. Once submitted, the Home Assistant can send notifications through your Telegram bot. So now we edit the configuration YAML. This is the core config file for Home Assistant. You use sudo nano to open it. The code on the right shows the reCamera dashboard and sensor configuration. Something important is that you only replace content after the comment header shown on screen. Do not delete existing configuration above it. And you remember is the spaces only, no tabs, indentation matters. Save always with Control O and exit with Control X. So this is the automation that ties everything together. When the person count sensor goes above 0, it triggers the Telegram notification. On the right, it shows the full automation. The trigger watches the reCamera people count sensor, and the condition ensures at least one person is detected. So the action sends Telegram message. Also, you can edit automations.yaml with sudo nano. Paste the code exactly as shown, save and restart Home Assistant to activate. So you can also define the Telegram notification service in configuration. The code block on the right shows the exact YAML. So add the bot in the Home Assistant. You can just go to integration, find Telegram bot, click the three dots, and add your chat ID as an allowed recipient. So this connects your automation to the Telegram delivery channel. Without this, the automation triggers, but no messages get sent. So as the final verification for the reCamera track, the four checks. One is the dashboard shows live video. Two, person count updates in real time. Three, automation triggers on detection. And four, Telegram notification arrives on your phone. So if all four work, the full reCamera pipeline is operational. And the screenshot shows a successful Telegram notification. So if you see 401 on video means wrong RTSP credentials, no Telegram messages means check your chat ID and boat token. And also you can just give it 5 minutes after restarting before retesting. So that wraps up the reCamera track. Let's do a quick recap. What we covered, the Node-RED basics, SSCMA detection, dashboard setup, light bulb automation, and Telegram push notifications. So since this is an online session, there is no live demo today, but this is exactly what you take Home assignment will cover once you've completed the setup at home, you can record the results and send them over. So you can keep in mind that Home Assistant supports more than 2,000 platforms, no protocol barriers, and no vendor lock-in. In real projects, components change constantly, keep interfaces stable, so swap in one piece doesn't break the rest. Now let's take a 5-minute rest and we will start in part 3, Jetson line in practice. Is there anyone who have any questions in the reCamera part before we start the Jetson part? If anyone have any questions, he can ask. Okay, since no one have questions, let's move to the part 3, Jetson environment and SSH login. So SSH into the Jetson. First time you just type yes to trust, password won't show, that's normal. And the command prompt is success. If you cannot connect, just check the IP and power status. Same SSH process, no visible characters for password, just type and enter, verify the IP and power if connection fails. So you can keep in mind 4 points. The Jetson runs Docker containers and essential commands. I can share it with you. Just Docker PS, Docker logs, Docker restart. And also you need to verify that Frigate port 5000 and Home Assistant port is 8123. And you just need to follow these steps to copy the offline package to the Jetson via SCP. Step 1, you just use the SCP command to transfer the file. The exact command is on the screen. You just replace the IP with your Jetson address. You verify the transfer completed, SSH into the Jetson and check that the file exists in the home directory. And the SCP is just SSH-based file. Copy same credentials, same connection. So basic Linux navigation on the Jetson. Step 3, you just use the CD to navigate to the package directory. Next, you use ls to list the contents and verify everything is there. PWD shows your current location. ls-lh shows file size in human readable formats. The -d flag lists directories only. So these are essential commands. You'll use them every time you troubleshoot a Jetson deployment. So in step 5, you just check the logs with Docker Compose logs. Look for errors in the startup sequence. The useful command shows your essential Docker toolkit. Docker Compose PS for status, or Docker Compose logs for debugging, Docker Compose down and up for clean restarts. So there's also some common issues that you would face. Container not starting usually means wrong directory, and make sure you're inside the offline package folder. Port conflicts means another service is using that port, and you can check and fix each issue before moving on. So you need to remember that the IP camera is the hardware eye via RTSP. The EI camera is the intelligence layer, local on reCamera or centralized on Jetson. The RTSP is the critical interface connecting cameras to AI processing. So here you can edit Frigate config and save it, Control-O, Control-X to restart. You just enter the command docker restart frigates, and you can check the web UI for your feed. So here, the configuration file, it will contains the operation logic for the entire multi-camera system, the camera options for users replication. So the option 1 is to use USB camera. And if there is multiple cameras, you can change it to the next code. So you just verify all services, Frigate port 5000, and as I said, the Home Assistant port is 8123, Grafana, InfluxDB on their ports. So you should not assume that Frigate working means everything works. You just need to check each service, troubleshoot with Docker Compose PS and also Docker logs. So Grafana on port 3000, InfluxDB on 8086. You check the dashboard for live data, FPS, CPU, GPU load, detection counts, and no data means pipeline gap. Grafana is your ground truth for end-to-end operation. So you confirm live data before you proceed. So now part 4, advisor level solution selection, shift from engineer to consultant. So there is 3 areas: the cost calculation, performance benchmarking, and documented recommendations. So by the end, you'll justify hardware choices with numbers in client's 3D format. So here is some case studies. Industrial park security, 8 cameras, behavior detection. So step 1 is requirements analysis. Step 2 is hardware, which is Jetson or a Nano that will handle the load. Frigate zones for detection areas, and at the end is the cost. So that pre-stream figure backed by a spec sheets is what separates consultants from salespeople. So here the performance tuning, 3 levers. 1, lower resolution, and 2, it reduced the inference FPS 15 to 5, 2/3 reduction. 3 is the zone filtering, limit interface to relevant areas. 4, 24/7 stability, automatic stream reconnection, and container watchdog. So non-negotiable for production. So as a summary, the reCamera is fast deployment, low cost, zero code, but the limitations is a single stream, no scaling. Instead, the other hand, to recommend like a small retail, rapid POC, single point automations, anything beyond that, we should go to Jetson. So for Jetson, it can have like 8 to 16 streams, centralized managements, mature ecosystems. Also, it had some limitations like the high technical barrier, significant upfront costs. So it's recommended for like 4+ cameras, industrial security, and also centralized 24/7 operations. So this is some kind of decision tree. 1 to 3 cameras, you choose reCamera. 4 to 7, it depends on complexity. If it's simple, we can just choose multiple reCameras. If it's complex, we go for Jetson. More than 8 cameras, definitely Jetson, no exceptions. And if it's advanced, we can have some hybrid model, recameras at edge, Jetson as a central hub, best of both worlds. So now we have 4 deliverables. One, the system architecture diagram. Two, the demo video showing end-to-end operation. Three, the performance metrics from Grafana. And four, configuration checklist with all change settings. So here you can export and backup, and you can backup everything before submitting. So we come up to the end of L2, 3 layers mastered, the protocol, encoding, MQTT, RTSP, engineering parts, Frigate, Home Assistant, Node-RED, Grafana, and also consultants, selection of the framework, cost calculation, professional delivery. And what you're gonna take home is to build it, document it, send it back, and we can review everything. So congratulations of finishing L2. Thank you very much. And if anyone have any questions, don't be shy to ask.
Yeah. Can you hear me?
Yeah.
Definitely.
Yeah, thanks for presenting. Uh, Very well done. Are there any GitHub repos associated with what was presented this evening or this afternoon for you all? Also, any plans for ROS2 integration? Um, those are just my first two questions. Can y'all hear me? Hello?
Hello, Gary. Could you hear us?
Yeah, y'all cut out for a second there. Sorry, I may have cut out.
Okay.
Apologies. No, I don't know if you had heard. My question was any GitHub repos associated with this aside from what's available through hacks, any repos for the reCamera? Um, I guess was my first question. I'll start with that.
Yeah, definitely. There is a GitHub repository about the reCamera that you can follow. And also there is, I don't know if you have heard about Wiki. It's a Seeds website. It's also have some guidance about reCamera in very, very detail.
Okay.
How about
I
yours?
had yeah, no, I've read about the reCamera V1, V2. Really not up to speed. Kind of new to this, but I'll definitely look into that though.
Yeah, sure. Do you already have a reCamera on your hand or not yet?
No, sir, not yet.
Okay. So you are welcome to purchase it on our website, Seed Studio. Uh, for now, the price of real cameras is not over, maybe depends on where you're from, but I don't think it's over $40 to 50. And you can use it to redo what we did today on the L1 and the L2. And that will help you to sense how like good the camera is at and how easy to deploy.
A quick question. So we're talking about, the Jetson mode, Jetson Strong, right? So we're talking about RTSP cameras, right? Or
Mhm.
cameras that are capable of RTSP feeds. So you don't necessarily need a reCamera to use the reCamera package, I guess. Is that kind of what we're saying here?
So if you're using reCamera, it's you can use just reCamera on its own, and because it's already have the AI built in. But if you are using Jetson, it's not necessary to use reCamera. You can use any camera you have.
Okay, so to complete this challenge, could I use like a GM SL2 camera or a USB camera
Yeah,
or
you can
other
use both.
camera?
You can use
Okay,
USB camera or RTSP, both are fine.
okay, that's it.
Is
Good
there,
presentation.
oh,
Thank you.
yeah, welcome. Is there anyone else who have other questions? So for Alejandro, I saw your message. I'm working on a project, and we're planning on deploying 100 ray cameras, sending feed to several edge servers on a factory, and recommendations of the best encoding I could use for the ray camera. So you sure you want to deploy 100 ray cameras, or you would prefer to use one Jetson with multiple normal cameras?
Since it's midnight in Mexico.
Okay, no problem. We plan to for the rear cameras because of the image quality and costs. It's really the only available solution for this with PLE. Okay, Alejandro, I will send you a text message after the training and we can discuss that directly. And maybe I will connect you with one of our sales teams that will also help you maybe ever to finish your purchase and give you some better suggestions. Yeah, you're welcome. Anyone else have any questions? If no one want to open the mic, you can just share your question on the text message. Okay, since no one have any. Yeah, definitely. I can share with you the PPT file that it include already all the details. If you already have the reCamera or the Jetson, it will be easier for you to redo what we already did. And if you need any other materials, also we can share it with you, no problem. This is the open source information. Oh, great. Okay, anyone else have any questions?
Okay, seems there are no questions for the rest of us. So we will share the slides of our courses later via email to everyone. And just a kind reminder that if you are official rangers, we will share our latest like product news, product like resources to for the rangers in the group. And if you are not the official ranger yet, you could finish the task of the training and share the project or documentation with us, and then we will have an internal like evaluation for your project. If your project is great to go, then we would love to invite you as our official rangers, and our rangers could like enjoy some discount for our product purchasing as well. So thanks for everybody's join our courses today, and we were looking forward to the next session soon. Goodbye, everyone.
Bye bye, everyone.
Bye bye. Bye bye.